Hello, everyone. I am glad to share our work in CVPR 2023. I am from University of Science and Technology of China, and the title of our shared work is Dynamic Generative Targeted Attacks with Pattern Injection. In this work, we propose a dynamic generative model to craft transferable targeted adversarial examples, which can not only inject pattern or style information of the target class to improve transferability, but also learn specialized convolutional kernels for each input instance. In the generative model, we design a novel cross-attention guided dynamic convolution module and a pattern injection module. To support this method, we provide a comprehensive theoretical analysis on the model inference, and we state that injecting the specific pattern or style of the target class can improve the transferability of targeted adversarial examples, and we present extensive experiments to demonstrate the effectiveness of our method. We list some limitations of current targeted attacks. For instance-specific attacks, they only take advantage of the specific input instance with iterative gradient updating, and they rely on optimizing the classification score of the adversary desired class label to perturb the instance, which ignore the global data distribution. So, they tend to overfit the white box model and result in modest transferability of targeted attacks. For the instance-agnostic attacks, most generative attacks still rely on the target label and the classification boundary information of white box models rather than the realistic data distribution of the target class. And existing generative attacks apply the same network weights to every input instance in the dataset. Based on these limitations, we observe that more transferable adversarial examples pose two properties. 1. There are underlying dependency with the input instance. 2. There are strong semantic patterns or styles of the target class. Therefore, according to these two properties, we construct a causal graph to formulate the prediction process of classifiers. For the input images, we propose to group the whole causes of it into content cause and style cause, and we analyze the origin of adversarial examples. As shown in the figure, inspired by the analysis, we first propose to exploit the statistical correlation between target label and the style cause to craft adversarial examples. Therefore, we state that injecting the specific style or pattern of images from the given target class can generate targeted transferable adversarial examples. To this end, we propose a generative model to craft targeted adversarial examples by injecting the pattern of the target class, which includes a novel cross-attention guided dynamic convolution and a pattern injection module, as shown in the figure. For the cross-attention guided dynamic convolution module, we propose a static and a dynamic convolution kernel, where the dynamic kernel weight is calculated by cross-attention according to input features. Specifically, there are several learnable kernels and learnable attention queries that to weight each kernel. The final dynamic kernel parameters are weighted sum of all learnable kernels. So, benefiting from this dynamic and static mix-up convolution operation, our proposed generative attack model can inherit the advantages of both instance-specific and instance-agnostic attacks. For the pattern injection module, we design a pattern prototype, which is extracted from the features of target samples, and we propose an adaptive class norm layer for pattern injection to model the pattern and style of all the target samples. We use exponential moving average to update the pattern prototypes. Besides, we also theoretically investigate why our method is effective for boosting target attacks between two Gaussian distributions, and the final formulation shows a close underlying correlation between the optimal targeted adversarial perturbation and the embedding of target pattern or style. which also theoretically guarantees the effectiveness of our proposed method. Our objective function includes two distance loss and a local similarity loss, where the local similarity loss is proposed by previous work. Then, we conduct experiments to demonstrate the effectiveness of our method for targeted attacks against normal models. Among all baselines, our method can generate targeted adversarial examples with higher transferability than others. And we also test our method against robust models and input preprocessed defense. These two figures show the superior performance of our method. Then, we present some visualization results of our method. The first, second and third rows show clean images, adversarial perturbations and adversarial examples, respectively, and A, B, and C display the results of different target classes. That is French bulldog, fire engine and street sign, which indicate that different target classes lead to different patterns or texture styles of the generated perturbations and adversarial images. Finally, I conclude our contributions as 1. We propose a dynamic generative model to craft transferable targeted adversarial examples with a novel cross-attention guided dynamic convolution module and a pattern injection module. 2. Benefit from the dynamic convolution module and a pattern injection module. Our method can not only inject pattern or style information of the target class to improve transferable targeted attacks, but also learn specialized convolutional kernels for each input instance, which inherits the advantages of both instance-specific and instance-agnostic attacks. 3. We state that injecting the specific pattern or style of the target class can improve the transferability of targeted adversarial examples, and we provide a comprehensive theoretical analysis to verify the rationality of this statement. 4. We present extensive experiments to demonstrate the effectiveness against normal and robust models. Okay, that is all of my presentation. Thanks for your attention. If you have any problem, please feel free to contact me.